Alright guys, welcome to Math 0314, Lesson 2.2, Introduction to Slope. So the first question is, what do we mean when we say slope? Well, a slope is typically defined as rise over run. And what that means is, if you have a line, every line has a certain amount that it rises and that it runs. Okay, and there's a couple ways of thinking about this. One way is to think about the coordinates. So let me draw this out again. Okay, so if I have a line like so, let's say I have the coordinates 0, 0, and then we'll do 3, 4. 3, 4 first off is when the x goes 3 and the y goes 4, but we said it's rise over run, so it's if it rises 4, then it runs 3, right? Just visualizing this, right? But what did we actually do? Well, if we label these coordinates as x1, y1, and x2, y2, when I say it's 4, what I'm really referring to is that the y2 value here is minus the y1, right? 4 minus 0 gives me a distance of 4. Right? If that's not clear, let's draw another line. I'll stay with the blue. Oops. And let's say this time it goes through 1, 1, and 4, 5. Something like this, right? Here we can see that the slope is actually the same. It's still 4. I rose 4, and I ran. Oops, I'm sorry. It's not the same. 4. Yeah, no, it is. I rose 4 and ran 3, right? But how did I get 4 here? It's not that I went like here. It's just I see that I 4, and so I said, okay, it's 4, and here say it's 5, so I just say 5. No, it's the difference between these, right? 5 minus 1, y2 minus y1. And the same thing is true for the x's. If this is 1 and this is 4 down here, then I went 4 minus 1, right? Or x2 minus x1. So slope is rise over run, but this is also y2 minus y1 over x2 minus x1. The other thing here that's very, very important is that what is slope in terms of the real world? Slope is a rate. Okay, the most common one is probably you think about. We know distance is equal to rate times time. And if I divide through by time, distance over time is rate. And what I'm saying basically here is that when you get in the car and you drive, you get something called miles per hour, right? Miles per hour is a rate, and that's significant. And a lot of people sit here and see this and think of this as some abstract notion that you use in a math class, and then you're never going to see it again. But it has effects in all different arenas. So if you're buying a car, right, you want to know how fast the car can get, right? That's a rate. If you're investing money, you want to see what your rate of return is, right? Then you would calculate the slope. There is a virus going on right now, and if you wanted to see you would want to see the rate of infection to see the chances of you contracting the disease, for example. Okay, so these are several different instances of slope, and it's very, very important. In fact, if you decide that you want to pursue more math, you'll see that the further deeper you get into math, the more and more we talk about this idea of rate. So, with that being said, hopefully I've sold you on rate a little bit, and rather sold you on slope a little bit. Let's look at the problems that we're going to be dealing with. So, you have this situation where you have a line, it's we see that we're rising 15 and we're running 5, so the slope would be what? Well, slope is rise over run. I encourage you to write that out over and over again until it's stuck in your head. So 15 over 5, which is 3. By the way, rise over run is easy to remember. Just think you rise up in the morning and then you run to your computer to do your math homework, right? Do me a favor, if you haven't done so already, pause the video and try this next one on your own. You should be able to do this quite easily on your own. And I'm going to assume that you've done that. So what did I do here? Well, again, the slope is rise over run. Hope you write that out so it starts sticking in your head. So I rose 6, I ran 4. That reduces to 3 over 2, and there's my answer. Moving right along, this is more of what you're really going to see, which is I give you 2 points and I ask you for the slope. Now, one way is to be intuitive about this and just draw an XY grid. Let's say 7 is here, 2 is here. It doesn't have to be super exact. Notice I'm not using graph paper here. I'm just kind of drawing points. So this one here is going to be 1. Let's say this is 1, this is negative 1. So we have a line as such. Let me erase this one. I don't know why I put that there. Okay. And so we're looking for the slope. So we're doing the same thing. We're trying to figure out how much up and how much over we went. So if you look at this picture, it's very clear that I jumped 1 and then 2. So that would be a distance of 3. Or 2 minus negative 1 is 3. And let me do this color code this. How much did I run? Well, this is at 7 here, and this is at 1 here, right? So this would be 7 minus 1, which is 6, right? You can clearly see that that is 6. All right, so what's the slope? 6 over 3, which is 2, right? But what did I really do? Well, what I really did was I used that other formula, right? I used y2 minus y, well, let me color code it still. The y in blue. y2 minus y1 over x2 minus x1. And we can see that that's exactly what I wrote off to the sides here, right? The y values, this is y2, this is y1, right? Which is, by the way, I apologize, this should be 3. This is incorrect. Forgive me, this is a common mistake. It's rise, which is 3, over run, which is 6, which is 1/2. I apologize. Hopefully that is clear, right? And then on this one, over 6, which is 1/2. So hopefully that is very clear. Again, let me reiterate that. And I'm not editing this out because I think that this is a very common mistake, right? We do the rise first, and then we do the run. Okay? So notice rise and then run, right? So the rise, the y value comes first, which is this, and then we have the run. So hopefully I've hammered that down. But you could normally students at the end of the day do y2 minus y1 over x2 minus x1 to get the answer. So hopefully that makes sense. Go ahead, and I have a bunch of problems for you to try on your own. Go ahead if you haven't done so already. Try number 4. Try number 5. Try number 6. Try number 7, try number 8, try number 9, try number 10, yeah, and that's it. Okay, so these are all more of the same. You may get some strange answers as you work through, but try to do these on your own. If you get stuck, just listen to me as I'm about to explain one of them, then pause the video, try on the rest of them on your own. But try them, the more you do on your own, the better you're going to be. Okay, so I'm going to assume you've given it a go, and let me label this. This is x1, y1, x2, y2. Like I said, once you understand what's going on, it makes more sense to just jump straight into the formula, the change in y over the change in x. By the way, I don't have to do y2 minus y1 over x2 minus x1. I could flip it. I could say y1 minus y2 over x1 minus x2. And how you label it, it doesn't matter as long as you're consistent. So what I mean by that, let me stress this here. If I'm going to label this x, the first one x1, I'm going to label the x component x1, then the y component must be y1. And the same thing over here. If I'm going to label the first one x2, then the second one has to be y2. What I'm trying to say here is you can't go x1, y2, x2, y1. You can't just mix and match. But you can switch these. So if I wanted to say that this is x2 and this is y2 and this is x1 and this is y1, that would be okay. Alright, so hopefully I've hammered that point down. And once we've done that, notice also I want you to realize I labeled this here because, as you can see from the previous example, it's very easy to make a silly mistake. Once I've labeled the top as y2 minus y1, I just substitute in the values, x2 minus x1. Watch those negatives. Okay, so 8 minus 5 is 3, 6 minus negative 4 is just 10, and there's my slope. So that's essentially all I'm going to be doing on all these problems. So hopefully that makes sense. Hopefully you've tried this one already, but if you were confused, hopefully that previous example makes life a whole lot easier. Give it a shot. I'm going to assume you've done that. Let me do exactly the same thing. So x1, y1, x2, y2. Again, I'm going to map those together and those together so that when I substitute into my formula, there aren't any issues. So we have negative 1 minus negative 4. Watch those negatives. And then we have negative 5 minus 3. And so when I clean this up, I have negative 1 plus 4. Negative and negative becomes a positive. Negative 5 minus 3. This leaves me with 3 over negative 8. And there's my answer. Okay. One thing I do want to stress here is that on this one, if you graph it, then what we'll see is that the slope here, and I tried to make it a little clear here, is we have the slope right here, right? And the slope is negative 3 over 8. And you can see if this is at negative 1, right, and I drop to negative 4 here, that obviously is a distance of negative 3, right? 4 minus 1 would be 3. And then if this is at 3, and this one is at negative 5, this is 5 and this is 3, so the jump would be 8. What I really want you to notice, though, is not the slope, but not necessarily the measurements of the slope. What I actually want you to notice is the direction of the slope, and this is very, very important. The slope of this one we can see is going down, right? This slope is going down. We can see it's going downhill, whereas in the previous examples, the slope has been always going up, like so. And this is because the slope is negative. So one characteristics of negative slopes is that you can always make the letter n, okay, because they have a negative slope. But realize that they are going down. Okay, moving right along. Again, if you were struggling before, please pause the video and try this on your own. See if you can get this on your own. I'm going to assume that you've had a shot at it, you had a go at it. That's the ugliest looking Y1 I've ever written in my life. There we go. Again, I'm going to label so I don't make a silly mistake. We have negative 4 minus negative 8 over negative 5 minus 1. So again, negative and negative becomes a positive, so this is just 8 minus 4, which is 4. Over the bottom is going to be negative 6. This breaks down to negative 2 over 3. And there we have it. So hopefully that makes sense. Again, if you were to graph this one, hopefully realize however this goes, this is a very quick sketch. This thing is going to be going in a downward direction. Okay. Again, if you haven't done so already, pause the video, give this a shot on your own. going to assume that you've done that. And I'm going to go through and solve it. So again, the slope is y2 minus y1 over x2 minus x1. I hope every time you write that down, so you start memorizing that, start sticking in your head so you don't make a little silly mistake. Okay, watch those negative signs. And so this breaks down to top is -6. On the bottom, we get 0. So this is another interesting scenario. We've mentioned this before. When 0 is under, the slope is undefined. But another question should emerge in your mind, which is, what does this graph look like? And that's an excellent question. Glad I asked it. That line looks like this, and we realize that the line is going up and down. So realize that when you see a line going up and down, it's undefined. Okay, so hopefully that's okay. Let's move on. All right, so again, do yourself a favor, pause the video if you haven't done so already, try these on your own. Try this on your own. And so, again, you're going to see, what am I going to do? I'm going to write the formula out. I'm going to map these so I don't make a silly mistake. Substitute in my values, being very careful. Right? And we're going to see the same sort of effect. So negative negative becomes a positive. So this is 7. 5 minus 5 is 0. 0 is under. It's undefined. Okay? Moving right along. All right? More of the same. I'm going to sound like a broken record here, but hopefully you've tried this. And if you haven't, hopefully you're pausing and you're trying. Okay? So, label. Write the formula out. y2 minus y1 over x2 minus x1. Label. And solve. Now, this is also interesting because when you have 0 on top, then that means that it's going to equal 0. So what does a slope of 0 look like? So if we look at this, we can see that this line right here is a horizontal line. And so when slopes are 0, you can make the letter Z, which means it has a 0 slope. Okay? So from this, we know now that if the slope goes up, it's a positive slope. If the slope goes down, it's a negative slope. If the slope goes up and down, it's undefined. And if the slope, is horizontal, or just a straight horizontal line, then it's 0. So this is a positive slope. This is a negative slope. This is an undefined slope. And this is a 0 slope. If you can pay attention to these facts on tests that are difficult, you can oftentimes eliminate answer choices because you can see what's positive, what's negative, what's undefined, and 0. So just by looking at the graph, you can oftentimes eliminate answer choices. Very important to know, very useful. Showed you ways to memorize them. Please get these in your head. Okay, get once more. If you haven't done so already, pause the video, give it a shot, try it on your own, and then we will tackle it together. And you can hopefully see that what I'm doing is I'm writing my formula, y2 minus y1 over x2 minus x1. You can see I'm not getting lazy here. I always rewrite the formula because the more I write it, the more it's going to stick in my head, right? And then we subtract. And when we subtract, we pay attention very closely to our signs, and we see we get 0 again, so this one has a slope of 0. Which I hope you know a slope of 0 means the line would be a horizontal line at y equals 6. Okay, cool beans. Alright, so So the next question is, given the slope is negative line, what is the slope of a parallel line? Okay, so first off, we got to talk about what parallel lines mean. Okay, lines are parallel. Okay, hopefully my drawing is accurate enough for you. If they never touch, okay, the only way these lines are never going to touch is if their slopes are the same. Now, in this case, whatever's going on here really should be, the picture should look something like, let's see if we can get a little more parallel. There we go. A little more parallel. The slope should look something like this. And my question to you is why? And I hope you answered that question by saying it's negative slope, so they should be going down, not up. Okay, so they have to have the same slope. So if the slope is negative 5, what is the slope here? It's going to be negative 5 if it's parallel. Perpendicular lines have what's called opposite reciprocal slopes. Okay, so remember in math, opposite means that you make it negative, and reciprocal means that you flip numerator and denominator. So, for example, if I had a slope of 2/3, the opposite reciprocal would be you negate it, you make it, and then you flip. So negative 3/2. Another example would be if I had a slope of negative 5/7, then I would change the sign, which actually means I'm negating it, right? So a negative negative becomes a positive, and then you flip. Okay? In our particular example, we are given a slope of negative 5, which is negative 5/1. So if I have a slope of negative 5/1, I'm going to change the sign. So now this is positive, and then I'm going to flip it, 1/5. Okay, numerator and denominator change position. That's all there is to it. So, if you haven't done so already, pause the video, give this a shot. This says negative 4/3. Okay, so go ahead, try it on your own. Hopefully you've done that. Parallel means what? It means you have equal slopes. So it should be negative 4/3. I also like it because the parallel lines are in the word parallel, and then if you take that, the two L's, and you turn it sideways, you get equal to. So that's my way of remembering that. Perpendicular is opposite reciprocal, so if the slope is negative 4/3, opposite reciprocal just means you change the sign. So now we're positive, and you flip numerator and denominator. And there you go. That's it. So moving right along. Number 13, are the lines parallel, perpendicular, or neither? Okay, so we've added one more step, which is really a combination of what we've done thus far. You're just essentially going to have to find the slopes of both these lines. So I'll label, I'll mark, I'll write the formula out, and I'll substitute in. Okay, negative negative becomes a positive. So the first one has a slope of 2. This is for line 1. Then we're going to jump to line 2. We're going to do the same thing. I'm going to label. We're going to write the formula out. I'm going to label y2 is negative 1 minus y1, which is negative 6, over x2, which is negative 3, minus 5. Negative negative becomes a positive, so this is 6 minus 2, which is 4. Negative 3 minus 5 is negative 8, and this becomes negative 1/2. So what happened here is that we changed the sign, and we flipped, and when that happened, we know that the lines are perpendicular. that makes sense. Moving right along, this is the one for you to try. So go ahead, pause the video now, and try to figure out whether the lines are parallel, perpendicular, or neither. So I'm assuming that you've given this a go, and we're now going to do this together. I'm going to label it x1, y1, x2, y2. Figure out my slopes first, right? That's the first move. Hopefully you know the slope formula is y2 minus y1 over x2 minus x1. Substitute in values. Change the signs. And this one becomes -1. We do, again, this is for L1. We're going to do the same thing for L2. We're going to label the points. Okay, write the formula down. And then I'm going to substitute it in. So the y2 values are 0, minus 3. The x values are 2 minus -1. Apologize, I should have labeled that. And so this becomes -3. Negative becomes a positive. So this is 3, and this gives me -1. Now notice here, they are the same. So when they are the same, they are parallel. Okay. Please be advised, I think that's it. Yeah. Please be advised that when you're working through these problems, you can get neither. Okay. Common cases of neither that they like to give you is -2/3, and then the next slope is -3/2. This is neither, and you may be thinking, but Mr. Anderson, I flipped it. It doesn't matter. You have to also, for it to be perpendicular, you also have to change the sign. Okay, so be very careful. Watch yourself. Your mind does want it to be parallel and perpendicular when you see these. But hopefully this makes sense, and you're working through, and things are going okay. I'll see you guys in the next video.